Here, this function gx is the transformed function of fx. But you need to know this is the original function. That you say, here you need to consider what is the specific graph of this original function. This time, you should not draw the function fx randomly because this function's expression has been given. Okay, it's easier for us to figure out this original function. That you say fx equals x. This is a straight line. You know this function is a kind of base function. Okay, on the basis of this function, we want to figure out this transformed function. But here, first, we need to focus on this part. Because this plus 4 is just an addition on the basis of this part. If you can figure out the value of fx minus 11, you just need to add 4, then you can get gx. Now, you need to compare this function and this. You know, you can consider this x as x0, that you say you need to take a specific value for this x. We assume x0 is a specific value of x. Now, if you want to guarantee this part equals the x0, you need to guarantee this x equals x0 plus 11. So this x should be greater than this x0. Between this x and this x0, the difference should be 11. So, on the basis of x0, you need to add 11 to get this x. Okay, that you say, after this analysis, we need to move the space function to the right side, by 11 units. That you say, this x should be greater than this x0. The difference is 11. X equals x0 plus 11. For every x0 on the original function, the corresponding x0 plus 1 should be here. X. The difference is 11. But you need to guarantee y coordinate. Does not change. So the corresponding point should be here. Okay, if you can figure out one point on this function, you can figure out the other points on this function. That will say, for every point, you need to guarantee the y coordinate does not change. So you need to figure out the new x specific value. It should be here. This difference should be 11. Okay, after you locate the new point, for every point, you just need to connect every point. You can get the new graph for this function. This new function should be like this. That to say, we need to translate this function to the right side by 11. 11. Here, also 11. Okay, after you have got this graph representing this function, if you want to figure out this function's graph, you just need to at 4 on the basis of the value. This value represents the y-coordinate. So for every point on this graph, you need to guarantee x coordinates unchanged. You just need to get the corresponding fx minus 11 plus 4. Here, we assume this is the fx minus 11 plus 4. So you get the first corresponding point. Similarly, for every point on the blue graph, you need to guarantee x coordinate unchanged, but you need to, on the basis of the points y coordinates, at 4. So the corresponding point should be here. If you can get every point, you can connect every point to construct the new line. This new line represents the graph of this function. So you will get here, it should be 4. This is the point. Similarly, for this point, it should be 4. You need to guarantee x coordinate does not change, but the y coordinate should be greater than this point. It should be here. Similarly, you can get the other point, then you connect every point. Then you can get this fx minus 11 plus 4. This is the transformed function gx.